Hi students, in this session I am going to discuss an excellent trick to solve limiting reagent problems. You know what is limiting reagent, Nana? So limiting reagent can be defined as the reactant which is completely consumed in a chemical reaction is called limiting reagent, or the reactant which is entirely consumed in a chemical reaction is called limiting reagent. Nana? The reactant which is completely consumed in a chemical reaction is called limiting reagent. Now, if the reactants are taken in the same mole ratio as their stoichiometric coefficient ratio, in which all of these reactants gets completely consumed in the reaction. If the reactants are taken in the same mole ratio as their stoichiometric coefficient ratio, all of these reactants gets consumed in the reaction. Suppose A plus 2B gives C product. Here stoichiometric coefficient are A and B are 1 and 2 respectively. Okay, no, stoichiometric coefficients are 1 and 2. So these reactants are present in these reactants. The number of moles of these reactants is 1 and 2 respectively. Okay, so the number of moles ratio of reactants is same as their stoichiometric coefficient ratio. Hence, all of these reactants gets completely consumed in the reaction. Okay, no? If the moles of reactants are not taken in the same ratio as their stoichiometric coefficient ratio, at least one of the reactant gets completely consumed in the reaction. That is called as limiting reagent, and other reactants are left over in the reaction or called as excess reagent. Now suppose if you take A plus 2B gives C. Initially 1 mole A and 10 moles B are taken. So the mole ratio of reactants is not same as their stoichiometric coefficient ratio, because in stoichiometric coefficient ratio of these reactants is 1:2, but initially 1 mole A and 10 moles B are taken in this reaction. Okay, no? So you know how many moles of B gets consumed in the reaction, no? Yes, obviously only 2 moles of B gets consumed completely in this reaction. Okay, so here 2 moles of B gets completely consumed in the reaction. So now how many moles of B left over in this reaction, no? Here 8 moles left over in the reaction. Hence the reactant B is called as excess reagent. It is unreacted in the reaction. How many moles of B unreacted in this reaction, no? 8 moles B unreacted in the reaction. Only 2 moles of B gets completely consumed in the reaction. Here 1 mole of A gets entirely consumed in the reaction. Hence A is called as a limiting reagent. Okay, no? What is limiting reagent? The reactant which is completely consumed in a chemical reaction is called limiting reagent. Now, how to find the limiting reagent? In a given chemical reaction? Now, let me explain. Method to find limiting reagent. Method to find limiting reagent. Now here how to find? Here divide the number of moles of each reactant by its stoichiometric coefficient, and this ratio would be minimum for limiting reagent. For example, A plus 2B gives C. It is a stoichiometric equation. Initially 1 mole A and 5 moles B are taken. 1 moles A, or here 3 or 6 moles of B are taken. Now how to find the limiting reagent? So to find limiting reagent, number of moles of A upon stoichiometric coefficient and number of moles of B upon, so number of moles of A upon stoichiometric coefficient and number of B upon stoichiometric coefficient. So number of moles of A is 1 mole upon stoichiometric coefficient is 1. It would be 1. And number of moles of B is 6 moles upon its stoichiometric coefficient is 2. That is equals to 3. The minimum value would be 1. Hence A is a limiting reagent. So for example, 1 mole nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia. Now which is limiting reagent? For example, here initially if you take 1 mole nitrogen or 2 moles of nitrogen and 9 moles of hydrogen. Initially if you take 2 moles of nitrogen and 9 moles of hydrogen. Now how to find the limiting reagent? So here number of moles of nitrogen upon its stoichiometric coefficient and number of moles of hydrogen upon its stoichiometric coefficient. Okay, cool. So now number of moles of nitrogen upon its stoichiometric coefficient. So number of moles, how many moles are taken? 2 moles. So 2 upon what is the stoichiometric coefficient of nitrogen? 1. That is equals to 2. Now the number of moles of hydrogen upon its stoichiometric coefficient. How many moles of hydrogen are taken? 9 moles. So 9 upon what is the stoichiometric coefficient of hydrogen? 3 equals to 3. So it is the minimum value. Hence nitrogen is called as a limiting reagent. Okay, it is clear? I hope you understand. So how to find the limiting reagent? Divide the number of moles of each reactant by its stoichiometric coefficient. The minimum value would be limiting reagent. Is it clear? Right. Now let us discuss mole analysis. Mole analysis. Put only limiting reagent into this analysis. Write mole analysis. Mole analysis. Put only limiting reagent into this analysis. Means the limiting reagent limits the amount of product formed during the reaction. Okay, so limiting reagent limits the amount of product formed during the reaction. Okay, no. So how much amount of product is formed during the reaction? So now how to calculate? For example, if you take 1 mole A and 2 moles of B to give C. So it is a stoichiometric equation. Let us consider it is a stoichiometric equation. Now initially if you take 2 moles of A and 10 moles of B, 2 moles of A and 10 moles of B. Okay, so now find the limiting reagent. So how to find the limiting reagent? Number of moles upon its stoichiometric coefficient. Now write mole analysis, put only limiting reagent into this analysis. If A plus 2B gives C, it is a stoichiometric equation. Initially if you take 2 moles of A and 20 moles of B, 2 moles of A and 20 moles of B. Now the limiting reagent can be find the number of moles of A upon its stoichiometric coefficient. How many moles of A taken? Here 2 moles upon 1, stoichiometric coefficient is 1, and B is taken in 20 moles upon its stoichiometric coefficient is 2. So that is equals to 10 moles and this is equals to 2 moles. Okay, no. So the minimum value it would be a limiting reagent. So where A is a limiting reagent and hence A limits the amount of product formed during the chemical reaction. Now what is mole rate? It is A is a limiting reagent and B is an excess reagent. So here how many moles of B consumed in this reaction? Okay, how many moles of B consumed in the reaction? So how to find that one? Okay, no. So number of moles of A upon stoichiometric coefficient, that is equals to 1. This is equals to number of moles of B consumed in a reaction upon its stoichiometric coefficient is 2. That is equals to number of moles of C, that is product formed during the reaction, upon its stoichiometric coefficient is 1. So this is the mole relation. Okay, no. Now we have to put only limiting reagent into this relation. What is the limiting reagent? No? Here A is a limiting reagent. So number of moles of A is 2 moles. 2 upon 1 equals to NB upon 2. So now how many moles of B consumed in this reaction? So number of moles of B consumed in this reaction is equals to cross multiply 2 into 2, that is equals to 4 moles. Here 4 moles of B consumed in this reaction and how many moles of B left over in this reaction? Here total 16 moles left over in the reaction. 16 moles of B remaining. Okay, no. So now how many moles of C produced? How many moles of C formed during this reaction? Now, so how many moles of B formed during this? How many moles of C formed during this reaction? No? So we know mole relation Na upon its stoichiometric coefficient equals to number of moles of C upon its stoichiometric coefficient is 1. So now Na number of moles of A is equals to how many moles here? 2 moles. 2 upon 1, that is equals to Nc upon 1, that equals to Nc equals to 2 moles. So how many moles of C is formed during this reaction? 2 moles of C. 2 moles of C formed during the reaction. Okay, no? So this is the mole analysis. Put only limiting reagent into this analysis. So limiting reagent limits the amount of product formed during the reaction. Okay, cool. Now let us take one example to solve limiting reagent problem. So when 22.4 liters hydrogen mixed with 11.2 liters of chlorine at STP, number of moles of HCl formed is equals to okay. Now this is the problem. So when 22.4 liters of hydrogen mixed with 11.2 liters of chlorine at STP, so how many moles of hydrochloric acid is formed during this reaction? Now let us write the equation. Hydrogen plus chlorine gives rise to HCl. This is a stoichiometric equation. Here 22.4 liters of hydrogen which means 1 mole, because at STP conditions gas occupies 1 mole gas occupies 22.4 liters of hydrogen, right? So 22.4 liters nothing but 1 mole. So initially it is taken 1 mole, and 11.2 liters of chlorine, 11.2 liters nothing but 0.5 moles. So chlorine is 0.5 moles. Now which is limiting reagent? So how to find the limiting reagent? Number of moles upon stoichiometric coefficient. It is 1 mole, 1 by stoichiometric coefficient is 1, and number of moles of chlorine 0.5 moles upon stoichiometric coefficient is 1. So this is equals to 1, this is equals to 0.5. It is the minimum value, hence chlorine is a liquid formed. So number of moles of Cl2 upon stoichiometric coefficient is 1, that equals number of moles of HCl upon stoichiometric coefficient is 2. So now how many moles of HCl is formed now? So now number of moles of chlorine, how many moles now? 0.5 moles. 0.5 upon 1 equals number of moles of HCl upon stoichiometric coefficient of HCl is 2. So number of moles of HCl formed during this reaction is 0.5 into 2, that is equals to 1 mole. So 1 mole HCl is formed during this reaction. Okay, cool. This is a very important